Hi, my name is Rania Hossam. I am delighted to share our AI automated safety system for self-driving cars. We all know that without a safety system, drivers can easily become distracted while on the road, whether it's from their phone, eating, or other activities. This can lead to accidents or near misses, also increase the risk of fatigue-related accidents. A driver who is tired may not be able to react as quickly to changing road conditions, increasing the chances of an accident, may be more likely to speed or engage in other risky behaviors on the road, such as aggressive driving or tailgating, have difficulty seeing or detecting objects in their blind spots, which can increase the risk of accidents, especially when changing lanes or backing up. Overall, our driver safety system can help mitigate these risks by providing drivers with real-time feedback and alerts on potential dangers, and assisting them in making safer driving decisions. We have 3 features in this code. The is driver looking at road. Function can detect if the driver is not paying attention to the road, which is a common cause of accidents. The is driver holding steering wheel. Function can detect if the driver is not holding the steering wheel properly, which can be an indicator of fatigue, distraction, or impairment. The is driver maintaining posture. Function can detect if the driver is not maintaining proper posture, which can lead to reduced reaction time and impaired control of the vehicle. By integrating these functions into an AI driver safety system, the system can monitor the driver's behavior in real time and provide warnings or alerts if unsafe behavior is detected. This can help prevent accidents caused by distracted, fatigued, or impaired driving, ultimately making the roads safer for everyone. Additionally, the data collected by the system can be used to improve driver training programs and inform the development of safer vehicles and roads. Let's talk about the 4th feature it detects, whether the driver's hands are on the steering wheel while driving. This is important for safe driving because it helps ensure that the driver is in control of the vehicle and can react quickly to any unexpected events on the road. If the driver's hands are not on the steering wheel, plays an alert sound to remind the driver to place their hands back on the steering wheel. This can help prevent accidents and keep the driver and passengers safe by initializing the media pipe hand detection model and loading a sound file for the alert. Then, it sets a delay of 5 seconds before starting the detection. Loops over the frames from the video stream captured by the camera, converts the frame to RGB format, and runs the hand detection model on the image to retrieve the hand landmarks. Then extracts the position and orientation of the hand landmarks and determines if they are on the steering wheel. If the hands are not on the steering wheel, the script plays the alert sound in a separate thread. Let's talk about the 5th feature. Drowning and yawning detection can help prevent accidents caused by driver fatigue or loss of consciousness while driving. By alerting the driver to take a break or stop the vehicle, the system can help prevent accidents and keep the driver and passengers safe, helping them stay alert and focused on the road. This can improve the driver's driving behavior and prevent accidents caused by distractions or drowsiness. Enhanced driver experience. By adding these safety features, uses the MediaPipe library to perform pose estimation on a camera stream and uses the results to classify whether the driver is wearing a seatbelt or not. The MP_drawing and MP_pose modules from the MediaPipe library are imported to provide visualization and pose estimation functionality. The math module is also imported for mathematical operations. The code initializes a text-to-speech engine using the PITX3 library and loads a pose estimation model using the MP_pose function. The camera stream is then started using the CV2.
Drowsy warning, you looks tired. Please take rest and drink some coffee. Drowsy alert, it seems you are sleeping. Please wake up, you are in a car, bro.
Video capture function. In the main loop, each frame from the camera stream is read and converted to RGB format. The pose estimation model is then used to process the image, and the distance between the shoulder and hip joints is calculated using the coordinates of the corresponding landmarks. Based on the distance, the code classifies the driver as either wearing or not wearing a seatbelt. If the driver is wearing a seatbelt, the text-to-speech engine will say, "Driver is wearing a seatbelt." Otherwise, it will say, Driver is not wearing a seatbelt. The pose landmarks are then drawn on the image using the MP Drawing Drawl and Marks function, and the resulting image is displayed using the CV2 ImShow function. Finally, the Cap Release and CV2 Destroy All Windows functions are called to release the camera stream and close the window. The Engine Stop function is also called to shut down the text-to-speech engine. Uses the Ho transform algorithm to detect and draw lines on the road in a video of a car driving. The code reads a video file using OpenCV, applies a Gaussian blur filter to the frames, converts them to HSV color space, and applies a color mask to isolate the yellow lines on the road. The canny edge detection algorithm is then applied to the masked image to detect edges. The CV2 How Lines P function is used to detect lines in the edge image, with the parameters set to detect lines with a minimum length of 50 pixels and a maximum gap between line segments of 50 pixels. The detected lines are then drawn on the original frame using the CV2 Line function. This feature can improve safety by detecting lane departures and issuing warnings to the driver, guiding autonomous vehicles, and providing feedback to drivers on their behavior. By helping to prevent accidents caused by lane departures, this feature can contribute to the overall goal of improving road safety.
Hello everyone, welcome to hardware section in our project. Today, I'm excited to share with you our latest creation, a sensor system that uses artificial intelligence models to detect objects around it. The system uses an ultrasonic sensor to calculate the distance between the sensor and the other objects in real time. If the distance between the sensor and an object is less than or equal to 1 meter, a buzzer generates a tone of caution to alert the user of the potential danger. This project is an excellent example of how technology can help us stay safe in various settings, according to our Safe Driver coaching system. So, let's dive into the details and see how it works. First of all, we designed and built the sensor system using the Arduino environment, which makes it easy for us to simulate and test. The components we use to create the system include an Arduino Uno ultrasonic sensor, wires, and a buzzer to generate tones of caution. Let's take a moment to explore how the sensor system works in action. To demonstrate this, we have created a simulation with 2 cars. The sensor system is located in the red one, and it's responsible for detecting other nearby cars. When another car approaches the red car, the ultrasonic sensor in the sensor system measures the distance between the 2 cars. If the distance is less than or equal to 1 meter, the buzzer generates a warning tone to alert the driver of the potential danger.
AI model to detect potholes on the road, which can improve driver safety by providing real-time warnings to drivers about upcoming potholes. This can help drivers avoid accidents, damage to their vehicles, and reduce the cost of road maintenance. Additionally, the dataset can be used to analyze the frequency and severity of potholes in different areas, which can be used by city planners and road maintenance teams to prioritize repairs and improve overall road conditions. Defines functions to convert bounding boxes in YOLO format to XMIN, IMIN, XMAX, IMAX, and to plot images with the bounding boxes. It then uses the YOLOV 8N model to train on the pothole dataset for 5 epochs, validate the model, and predict on the validation set. Finally, it defines a function to visualize the results of the prediction on the validation set by plotting the images with bounding boxes in a 2x2 grid. YOLOV 8 is an object detection algorithm that is well suited for tracking vehicles on roads. By training the model on a set of labeled images and videos, YOLOV 8 can accurately detect and track vehicles in real time, allowing traffic authorities to manage traffic more effectively. After detecting vehicles using YOLOV 8, tracking algorithms such as Deep Sort can be used to track vehicles across frames, providing traffic authorities with the speed and location of each vehicle and even counting the number of vehicles on the road. The use of YOLOV 8 for vehicle tracking is revolutionizing how we monitor and manage traffic on roads, making our roads safer, more efficient, and reducing traffic congestion.